30. We're given a function here that represents the growth of some insects. T is the number of months since the experiment began. So what is the population of insects when the experiment began? So with the exponential functions, it's y equals a times b to the x, right? X is we're having t. The number at the very front, that tells you how many you started with. Because if you put in 0 for t, this becomes 1, right? 1.2 to the 0 power is 1. 1 times 5,000 is 5,000. So that's why that's always the y-intercept, the beginning value. By what percent does the population increase each month? So 1.2. And remember, that's the factor. So we turn it into a percentage. We multiply by 100, so that's 120%. And we subtract 100% because that's what we started with. And we can see it is growing by 20%. Positive 20% growth. By what percent does the population increase each year? So that would be, what we're looking for is a 12-time factor. So it's not just taking 20% multiplying by 12, it's taking 1.2 and raising it to the 12th power so that we have a factor that is a 12 unit growth factor, right? So let's take a look at what that would give us. 1.2 x to the y, and then we raise it to the 12th power. It's going to be an 8.92, just 2 decimal places. Remember, that's a percentage, so we multiply by 100, that's 892%. And again, we started with 100%. We always start with 100%. So that is a 792% annual growth rate. And notice if we took 12 times 20, that'd be 240%, which sounds big, but this is an exponential growth. This is what we get. Okay. Is your answer to part C equal to 12 times your answer to part B? Why or why not? Well, we just answered that. No, it's not. And the reason it's not because it's exponential growth. It's not a linear growth rate. It's not just 12. It's 20% each month, and so then the next month is 20% of that growth as well. So it's compounding it. I guess we could answer that way. No. The population of insects after 2 months will be what percent of the population after 1 month? Well, it will be 120% of it. That amount will be 20% more. which of the following expression represents the number of months needed for the population to go to 9,000 insects. So we would basically take our equation, right? When we're going to have 9,000, 5,000, 1.2 to the t. So we divide both sides by 5,000. 9,000 over 5,000 is equal to 1.2 to the t. And then we could do a change of base. And so if we're looking at what we have here, we're not actually going to carry that calculation out. But if we take the net, if we do the log dance, as I said before, the base becomes the base of the logarithm. So 1.2. This now becomes the input. And the exponent becomes the answer. So we're looking at what's different. Oh, I see there's a 1.2 here. I almost got that one, but no, it's this one. Right? 9,000 divided by 5,000, so that's all that. Log 1.2 raised to the t. So that's our answer there. And that is 30.